Hello, Math 1093. This is Cardinal Sins. Yeah, you'll get it in just a minute. In this video, we're going to talk about how to find the sines and cosines of some particularly important angles, all of which are fractions of pi. So remember from one of our previous videos that pi radians represents half of a rotation around a circle. So we start at the positive x-axis and we land at the negative x-axis. That is pi radians. So in light of that fact, what would cosine of pi be? And what would sine of pi be? Okay, so the important thing to remember for all of the examples we're going to do in this video, since all of these are unit circles, is that the cosine of some number is the x-coordinate we get to if we travel that many radians or that many radius lengths around the circle. And the sine of a number is the y-coordinate that we get to if we travel that many radians around the circle. Okay, so in this case, what does it look like if we travel pi radians? Well, that is half a revolution. So we travel halfway around the circle and we land here at the point -1, 0. So that means that the cosine of pi, that was pi units or pi radians. So cosine of pi is going to be -1. Sine of pi is going to be 0. Okay, and using this picture, I'm also going to show what happens if we travel pi over 2 units around the circle, or pi over 2 radians. So that's going to land us right here. That is an angle of pi over 2 radians, or 1/2 of pi. I like 1/2 of pi. It helps me to see this as a fraction of pi. Anyway, so for that one, because the point that we land at is the point 0, 1, that means that the cosine of 1/2 pi, or the cosine of pi over 2, is 0, and the sine of 1/2 pi is going to be 1. Okay, and we can use the same idea to figure out sines and cosines of other angles. Like, for example, suppose we travel around the circle 3/2 pi units. So 3/2 pi is going to be pi plus another 1/2 of pi. That's going to put us right here at 0, -1. So we can use that to figure out the cosine and sine of 3/2 pi. Okay, in the next picture, so let's just move over a bit here. Let's talk about a different kind of angle. So this time I'm going to mark off an angle of 1/4 pi radians. Okay, 1/4 of pi. Well, pi is all the way around this upper semicircle. It's half of a rotation around the circle. That's pi. So I want 1/4 of that. 1/2 of that was this first quadrant here. So 1/4 of pi is going to be half of the first quadrant. So that means I'm going to mark off this line here. Let's try and make that as straight as possible. I'm going to land here. Okay, so that is pi over 4 units. And this angle has measure 1/4 of pi radians. Okay, let's call the coordinates of that point x, y. I don't know immediately what those are, but I bet we can figure this out. All right, now notice that this line here cuts the first quadrant exactly in half. So there's some nice symmetry here that I can use. You'll notice, in fact, that this line, it's actually the line y equals x. And the equation of the circle is x squared plus y squared equals 1, because this is just a way of saying xy is a distance of 1 from the origin. So that means we're on the unit circle. Okay, my point in putting these things here, we know that this point here, this mystery point we're trying to find the coordinates of, it's on the line y equals x, which means that its x and y coordinates are going to be equal. And we also know that this point is on the unit circle, which means it has to satisfy this equation here. I can use that fact and a little bit of clever algebra to figure out what x and y are. So I know that x squared plus y squared has to equal 1, but I also know that x has to equal y. So I could substitute x for y in this equation and get x squared plus another x squared equals 1, which means that 2x squared is 1, which means that x squared has to equal 1/2. So that means that x is going to have to be the square root of 1/2, either positive or negative. And in this case, because the point I'm looking at is clearly in the first quadrant, I know that it's the positive version that I'm thinking about here. So x is the square root of 1/2, which we can actually rewrite as root 1 over root 2, and the square root of 1 is just 1, so that's 1 over the square root of 2. Sometimes your mean pre-calculus teacher will say, well, I'd like for the denominator of that to be a rational number, not a square root of 2. So you could also multiply this by square root of 2 over square root of 2 and get square root of 2 in the numerator, and then root 2 times root 2 in the denominator. That's 2. Okay, so what this means is that the cosine, let me move down a little bit and write this down. Okay, so what do we know? The cosine of 1/4 of pi is equal to 1 over root 2, the square root of 2, and that's also equal to the square root of 2 over 2. And because I know that x equals y for that point, the x-coordinate and y-coordinate are the same, I also know that the y-coordinate, or the sine of 1/4 pi, is also going to be 1 over square root of 2, or equivalently, square root of 2 over 2. Okay, by the way, in terms of degrees, the angle that we just talked about here is a 45-degree angle. I just want to keep track of it as we go along. Over here, that angle of pi radians was 180 degrees, and that angle of 1/2 pi radians was equal to 90 degrees. And we can figure out sines and cosines of degree measures the same way that we do radian measures. So for example, the cosine of 45 degrees is also 1 over the square root of 2, because that was equivalent to 1/4 of pi. All right, now let's move on to this picture. Okay, I'm actually getting kind of cluttered down there, so I'm going to move up here instead to do the work. All right, this time I'm going to draw an angle whose measure is 1/3 of pi. And we're going to figure out the cosine and sine of 1/3 of pi. Now this time, consider the fact that 1/3 of pi, that's 1/3 of 180 degrees. So that means that this angle here, its degree measure is 60 degrees. That's 1/3 of 180. Okay, so if that's 60 degrees, I could also draw another 60-degree angle here. And have a ray sitting at 2/3 of pi radians. Okay, we'll get to that later. But I want to figure out what the coordinates of this point are so that I can find the cosine and sine of 60 degrees. Because remember, the cosine and sine are just the x-coordinate and the y-coordinate at that terminal point. Now you notice here, there's a little bit of nice geometry in what I drew here. Because what I've drawn, this was a 60-degree angle here. And then this right here, that's also a 60-degree angle. So that makes this a 60-degree angle. So I'm going to put a little 60 degrees in there. 60 degrees, it's hard to say. 60-degree angle. And what else do I know? I know that this radius here has length 1 because we're on the unit circle. And this radius also has length 1. So those side lengths are equivalent. That makes this an isosceles triangle. And because it's isosceles, these angles here also have the same measure. And this angle measure was already 60 degrees. So these two angles are going to share the other 120 degrees worth of interior angles, which means each of them is 60 degrees. And once we have that, if we have a triangle whose interior angles are all 60 degrees in measure, that makes this an equilateral triangle. And that's nice because that tells us a lot about the structure of this triangle. Notice that I also know that two of the sides of this triangle have length 1, so that means that this other side, the one spanning the two top vertices, that also has length 1. And because of the symmetry here, I know this triangle is exactly split in half by the y-axis. That means that this side length here, or this half of this side, that has length 1/2. And this other half side also has length 1/2. So this tells me actually that my x-coordinate is equal to 1/2. So I can say the cosine of 1/3 of pi, or the cosine of 60 degrees, is 1/2. Because it's just 1/2 of this side here, and this side has length 1. Okay, so what about y? I need to figure out what y is. Well, to figure out y, I'm again going to use the fact that my point x comma y is on the unit circle. And if it's on the unit circle, then it satisfies the equation x squared plus y squared equals 1. So if I know x squared plus y squared is 1, and I know that x is 1/2, I can substitute that in, get 1/2 squared plus y squared equals 1. 1/2 squared is 1/2 times 1/2. That's 1/4. Plus y squared, that's equal to 1. If I subtract 1/4 from both sides, I get y squared is equal to 3/4. So that means that y is either positive or negative square root of 3/4. Which means, and in this case, we know that y is positive, sitting in the upper quadrant there. So it's going to be positive root 3 over root 4, which is equal to root 3 over 2. So that tells me that the sine of 1/3 of pi is going to be square root of 3 over 2. All right, let's do one more. What if I draw an angle whose measure is 1/6 of pi? So now I'm just going 1/6 of the way around this upper semicircle here. So that's 1/6 of pi. By the way, I just wanted to point out, because my artwork in the previous videos has been pretty lacking, but notice this point was exactly on 0.5. So x was 0.5 there, and that's exactly what turned out in the calculation I did there. We said that the cosine of 1/3 of pi was 1/2. Now I have to admit that's partly because I used that fact to draw the picture. So it's a little bit fake there. Anyway, so now I've got an angle whose measure is 1/6 of pi. What is that in degrees? That's 1/6 of 180 degrees. That's 30 degrees. All right, so I want to know the cosine and sine of that angle, which means I need to know the x and y coordinates of that point. But see, here's the thing. In this other unit circle that we just talked about, if you look at the right-hand side, or the right half of that equilateral triangle, what I had here was a 60-degree angle. This was a right angle. The right angle in this picture was that. And this other angle, this was half of a 60-degree angle, so that was 30 degrees. Okay. By the way, in radians, those are 1/6 of pi, and this was 1/3 of pi. There we go. And the dimensions of that triangle were, this was 1, this was 1/2, because it was half of 1. It was half of a side of an equilateral triangle. And this turned out to be square root of 3 over 2, basically using algebra. So now, in this picture, I actually have the same triangle. It's just I have to work a little bit to see it. If I draw this, though, I see that I'm looking at the very same triangle. This angle is 30 degrees in measure. This is a right angle, and therefore this angle is 60 degrees in measure. So the dimensions of that, again, are going to be 1, because we're on a unit circle, 1/2, because this can be viewed as half of a side of an equilateral triangle. I can extend that down if I want to. There we go. And therefore, by algebra, this has to be square root of 3 over 2. So x is root 3 over 2, and y is 1/2. So in this case, the cosine of 1/6 of pi is root 3 over 2, and the sine of 1/6 of pi is 1/2. All right, so now we have a nice little collection of sines and cosines for certain fractions of pi. Now, I can't do this for just any fraction of pi. For example, if you ask me what the cosine of 1/7 of pi is, I'm not going to be able to tell you, because there's not going to be any clever geometry that I can do that'll give me that, not like an exact value for it. But I do know the sine and cosine of pi, 1/2 of pi. Let me point to these: 1/2 of pi, 1/4 of pi. I even know it for 1/3 of pi. Where did those go? I think they're up here somewhere. There we go. 1/3 of pi. And I even know them for 1/6 of pi, which is a pretty good start. I can also figure out the sine and cosine for, say, 5/6 of pi. I would need to work my way around the circle until I reach 5/6 of pi, which would be somewhere around here, and draw the appropriate triangle. But it'd actually be this triangle reflected over to the left. So I'd be looking at a triangle somewhere around here. Okay, and we'll talk about how to do more of that in class. But one thing I want you to understand is that it's going to be very important to know these values. And it's good to practice working out the geometry, but eventually you're going to want to get to the point where some of these things you just know. And we'll talk about a couple of strategies for doing that in class. All right, see you soon.